So hey guys, and welcome back. I wanted to start a new part of the channel where we talk a little bit about plant identification. Plant identification is very important to anything in the outdoors, whether you're hiking or camping or surviving or trying to be self-sufficient or any of those things. It becomes very important to know how to identify plants. That makes it so that when you walk into your woods, you're not even only walking into a beautiful place, you're walking into your kitchen cupboard, you're walking into your medicine cabinet, into your tool shed, into your first aid kit, all of those things. But you do have to be able to properly identify plants because they do act like mushrooms in the way that many plants do have poisonous lookalikes. That you may identify a plant by a flower and say, okay, yes, this is yarrow, but it turns out that it's hemlock because you didn't pay attention to what the leaves or the roots look like or anything to that effect. So the first thing that we're going to start off learning through this subject is how to identify leaves over anything. Leaves can be the first thing that you look at to make sure that you have a proper identification. So I'm going to pull out my little whiteboard here. And I apologize that it is a calendar, but that's what I have right now, and I don't want to waste the paper. So the first thing we have to do is know the parts of our leaves. I'm not going to go into cell structure. I may make another video on that for people who really want to get into it. But I'm just going to do basic parts of the leaf from when you're looking at it. So if I draw a simple leaf with my awesome artistic skills, here we go. You have a few different main parts of your plants that you'd want to know. The very tip of your plant is what's called the apex, A-P-E-X. Then you have what's called the margin of your plant, which is the edges of it, just like the edges of your paper are your margins. Margins can be wavy, or they can be spiky, or they can have teeth, or they can be smooth, or etc. Then you have your veins. Your veins are those small indents that are all through your plants, just like the veins in our skin. Those are your veins. And then you have the base of your plant. All leaves will have these four structures, and put together, these four structures are called the blade. So you have the blade, which consists of your apex, your margins, your veins, and your base. Then plants have a few other structures that some leaves may have and some leaves may not have. The main one is called the petiole. It's P-E-T-I-O-L-E, the petiole. The petiole is pretty much the stem of the leaf. A lot of people see it and they believe that, oh, that's a piece of the plant itself, of the stem of the plant itself, but it's not. It's the stem of the leaf. So when you pull an oak or a maple leaf up off the ground and it has that little woody stem on the bottom of it, that's actually called a petiole. A petiole can be flat, it can be short, it can be long, soft, round, shiny, not shiny, wood-like, plant-like, etc. A good example for you to understand how much of a variation there is in what a petiole may look like. When you're eating celery, that stalk that you're eating is actually the petiole of the stalk's leaves. Now, if you have a plant that does not have any sort of a petiole, a good example of that is bananas, birds of paradise trees, anything like that, where that leaf almost acts like a sheath to the stem of the plant and kind of grows right out of it with no stem. That would be called a sessile. It's S-E-S-I-L-L-E, a sessile plant. Sometimes, again, not all plants have these, but some do, that when you look at the bottom of the petiole where it attaches to a plant, which is also where your axillary bud would be located, you may see two short, spiky leaves that petiole is growing out of. If, and again if, they don't all have this, if you see those leaves, that is called a stipule. S-T-I-P-U-L-E, a stipule. Again, stiples and petioles do not exist on all plants, but that is a good way that if you see a petiole, it may be able to say, okay, well, it's not this plant because I know this plant doesn't have a petiole. So again, you have four main components that all leaves will have: your apex, your margins, your veins, and your base. That creates the blade of the leaf, and then you may or may not have a petiole or a stiple. So if we grab my little eraser here, it's actually a piece of paper towel. The next thing we have to learn is how these leaves come together on a plant. Because you may have two plants that both have petioles, they both have stiples, the margins of the leaves are exactly the same, the veins are set up exactly the same, and the only difference is how those leaves are compounded to each other. The first basic ones we have, which I'm going to draw a little flower here so that we can have an idea. We got the stem of our flower. We have the ground, we'll make it like it's in a little pot here. And then we've got our flower at the top. It doesn't have to be a flower, just using an example. Where the leaves of plants attach to the stem is always called a node. And that is literally just the conjunction. You're not going to see a specific node. Sometimes it will have a bump from where the stem is swollen to push the leaf out, but it's just where that leaf attaches to the actual plant is called a node. So I'm just going to draw some little dots. They don't actually look like this. I'm just using it for reference along my plant, and we'll call those nodes. When a plant only has one leaf coming out of each node, so we'll draw a little leaf out of each node here on its petiole. That is called alternating. It has an alternating compound of leaves. So think about, you have 1, 2, 3, 4. That's alternating. So when only one leaf is coming out of your node, that has an alternating compound. If you have two leaves coming out of each node, so we'll put another leaf out each side here. I'm just going to draw them as little like triangles here. If you have two, and only two, leaves coming out of each node, that's going to be called an opposite compound. Think about, the leaves are facing opposite ways. Sometimes they'll be facing the same direction, but a lot of times they'll be opposite ways. So it's called opposite compound. Two leaves out of each node equals an opposite compound. Moving up from there, if you have more than two leaves, any number, can be 3, 4, 5, 6, 7, whatever. If you have more than two or more leaves coming out of each node, I'm just going to draw them each with 3. That's what's called a whorled compound. So it's going to be WHORLED. Think about it like something is whirling. The leaves are whirling around the plant. So you have more than two, not two or more than two, so 3 or more leaves coming out of one node. It's going to be called whorled. What whorls can move into, and this is where some people get a little confused, is that if we get rid of our plant here with all its whorled leaves, if you have a plant, I'm going to draw a dandelion because dandelions are our best example here of something that most people will know. If you have your dandelion, and you have a whorled set of leaves, so again, 3 or more coming out of one node, but it's only coming out of the base of that plant. So here's our ground, and you have 3 or more leaves coming from the base of that plant at the same node, so that the stem is growing out of that whorl of leaves at the ground. It's going to be called a basal rosette. BASALROSETTE. It's called the basal rosette, and again, that's only at the base of the plant. There would be no other leaves going up the rest of the plant. It just has a whorled of 3 or more leaves where it's coming out of the ground and then shooting a stem up. It's called a basal rosette. So those are the simplest compounds of leaves. Again, you have your alternating, which is 1 out of each node, opposite, which is 2 out of each node, whorled, 3 or more out of each node, or basal rosette, where you have 3 or more out of one node at the base of the plant. To get a little more complicated, we're going to get into some Pinelli and Palmetly compounds. The Pinelli, which is Pinnately, Pinelli compound is something you'll see in fern-like plants. I'm trying to think of other examples off the top of my head. Fern is probably the best one. But that's where, if I have my main plant, and I have a petiole coming out of my plant, we'll call that a petiole, and the petiole continues to extend nice and far, and you have tons of little leaves. I'm just going to draw them as lines coming off that petiole. It's going to be called a Pinelli compound. But what happens, this is where it gets a little more confusing and a little more in depth, is that petiole, the petiole ends where your leaf starts. We're going to draw a line there before all our leaves. Only this area would be considered to be the petiole. What it then turns into is what's called a rachis. It's R-A-C-H-I-S, is where that petiole continues way on, nice and long. You know, it technically be short and long, but has tons of little tiny leaves coming off either side. I'll draw those more as leaves here. So you got leaves coming off all over the place up this thing. Little leaves. That's going to be considered to be a Pinelli compound. Then you have what's called a twice Pinelli compound. And so you have your petiole. Again, it turns into your rachis. But then this rachis has rachises coming off of it. So you have a rachis, a rachis, a rachis, a rachis, 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 rachis. And the side shoot rachises are going to be the ones that have all your leaves coming off of them. Try to do this fast so you can see it here. And it'd be like that off all these side shoot rachis. So you kind of have a main rachis right here, and then all your side ones that are going to have your leaves off of it. That's still the Pinelli compound. It's just a twice Pinelli compound. So it's Pinellis coming off of Pinellis, pretty much. From there, we have what's called a Palmetly compound. There's going to be P-A-L-M-A-T-E-L-Y. A Palmetly compound is kind of going to be like a Japanese maple leaf, is going to be a palmetly compound. It's where you have what looks like multiple individual leaves, but it's actually one where these leaves are all coming back to a center base. Kind of like drawing a pot leaf here. Like a center base with its own veins, and it ends up kind of looking like a hand. That's called a palmetly compound. So that's a pretty easy one to remember. So those are your main compounds of how leaves come together. Again, you have alternating, opposite, palmetly, Pinelli, and twice Pinelli. Those are all the ways that your leaves are going to come together. Now that we know how our leaves come together, we need to know how to define the margins of each leaf. I'm going to go... you can go on forever about all the different types of leaves, but I'm going to do your main different 5 types. The first and easiest would be called entire. When you have an entire margin, it's just like the word entire, E-N-T-I-R-E, that just has a very smooth margin. Just your normal leaf, nice, smooth, unserrated margin. The next one is what's called a sinuate. It's S-I-N-U-A-T-E, a sinuate leaf. A sinuate leaf is where your margin is still smooth, but it's slightly wavy. So you're going to have something like that. Obviously neater than that. But still a very smooth margin. It's not jagged. It just has slight curves and waves to it. The next one is called your dentate. That's D-E-N-T-A-T-E. A dentate is where your margin has small outward poking teeth to it. So think about it like a jagged line. If your margin looks like that, it's called dentate. Again, the margin is the edge of the leaf. Then you have what's called a serrate. Your serrate is very similar to your dentate. It's going to have teeth all along it, but your teeth are smaller and usually curving one direction or the other, kind of like a saw blade. So it's going to look more like that. That would be a serrate. Excuse me. After serrate, you're going to have what's called lobed. Lobed is similar, to your sinuate. Jeez, I'm losing my words. I apologize. Lobed is similar to your sinuate, but it's more defined. Your lobes are kind of going to come all the way out and back in, and all the way out and back in, and all the way out and back in. Kind of like you would draw a cloud. That's your lobed. Well, just so that you can remember the difference, your sinuate is still smooth, and it just has very slight, wavy curves to it. So that you can see the difference. Lobed versus sinuate. So those are your main 5 different types of marginal structures. Okay, after all that, we're going to go over 2 more ways to identify your leaf type. And the first is by shape. The first shape you have is called elliptical. Elliptical is just basically an normal-sized oval. Normal proportions of width to height, etc. And it's just the shape of an oval. The next you have is what's called a lancelet. Lancelet, which is Lanceolate, lanceolate, is pretty much the shape of a triangle, with a nice point at the end and slightly curved bottom. The way I like to remember that one is Lancelot. It kind of looks like the tip of a spear or maybe a sword or something to that effect, so I think of it Lanceolate, Lancelot. The next one is what's called Ovate. Ovate is kind of a cross between the Lancelot and the Elliptical. It's kind of going to be like a triangle, but with all curved edges. The tip is curved, the bottoms are curved, etc. That's called an ovate. After ovate, you have what's called cordate. Cordate is your upside-down heart-shaped leaf. And your petiole would be coming out of the base of the heart. That's called your cordate. After cordate, you have what's called a hostate. This is an awkward shaped plant, or leaf, excuse me. And you're going to kind of have one spear coming out the middle, and then one coming out each side. So like that, that's called a hostate. And then the last one we have is what's called linear. Linear is just like the ovate, except for much longer. It's a very long, skinny, oval-like shape, usually at least twice the length as the width is going to be your linear. If you can't identify them by the shape, you can always identify them by the way that the veins are shaped. Veins that are linear means that they're all, if I have my leaf here, all your veins are going to come from the base of the plant and run the same length all the way up the leaf. So that's called linear. The same length coming from the same point at the base of the leaf and running up the leaf alongside of each other, so they are linear. Then you have pinnate, which is just like the compounds we were talking about earlier. That's where it comes from, is the pinnate, which means that you have one center vein, and then all your other veins are coming off that one center vein, just like how the leaves grow when they're pinnate. So that's a pinnate vein. Then you have what's called a palmate vein, which is just like the compound of leaves we talked about when it's palmate. That means that it has multiple central veins that all come back to the same point, but they run in different directions, are different sizes, and oftentimes have smaller secondary veins coming off of the main veins. That's called a palmate. Alright guys, the very last thing I want to talk about before we leave is specialized leaves that do not fit into any of the categories that we just spoke about. Mainly, I just think it's pretty interesting. The first one I want to talk about is what's called a bract. A bract is B-R-A-C-T, and these are specialized leaves that act as helpers and defense mechanisms. The best one that I can think of to give you for an example is a poinsettia plant. Those red flowers that you see on them at Christmas time are not actually flowers. Those are leaves, and the flower lies in the middle of those leaves. So what these specialized leaves do is they either produce colors and patterns that attract pollinators to the flower, or they repel predators to keep them from eating the flower. Another one that I want to talk about is what's called a reproductive leaf. The best example I have is a spiderwort plant. These are leaves that actually do the reproduction for the plant. They'll start growing a new little baby tiny plant off the end of that leaf. It's actually very cool to watch and makes it really easy to propagate those plants. Another one is called spines. These are a defense mechanism. Thorns on plants and the spines that are on cactuses are actually scientifically classified as specialized leaves. Another one is your succulent leaves. A good example of these are aloe vera. I also did another one in one of the Shenandoah videos we just made where we found some Allegheny stonecrop. That's also a succulent leaf. These leaves are very thick and they almost feel like rubber. Those are used to store mass amounts of water to help protect plants living in harsh conditions. Things in windy, cold areas, things that have to make it through winter time, etc. Those are called your succulent leaves. Another one is called your tendrils. When you have a vine plant such as your peas, you have your main vine, and off of that you'll have what looks like little mini tiny, almost, barely the thickness of a needle type vines that come out, and those are what tie to other plants and tie to your trellises, etc. Those are called tendrils, and those are also classified as a type of leaf. And the most interesting one I found is bulbs. So when you eat an onion and you pull that up out of the ground, you're not eating a root structure, you're actually eating a type of leaf. Each one of those layers that you can peel back on an onion is another leaf that's been modified and swollen for food storage. So that's pretty interesting. So those are just a few leaves that you can find and use to be able to determine your type of plant, but will not fall into the categories that we've talked about previously. So I just want to let you guys know that also. It's pretty interesting. But otherwise, thank you guys so much for watching. I am going to try to post videos soon that incorporate root structures, flower structures, etc. And we'll go more and more in depth and in detail with how to identify our plants, because it is, like I said before, very important to know these things when you're talking about survival or living in the woods or living self-sufficiently. And even if you're not doing any of those things, it'll save you a ton of money when you can identify plants, because you can make your own medicines, you can make your own food. I do quite a few too. I'm going to have some videos coming up on how to make a few different ointments with plants and things like that I use all the time that work amazingly. So feel free to definitely comment or message me, ask me any questions. If there's anything that I didn't go in depth with enough, or I didn't explain well enough, or you want to know more, just let me know. I'm absolutely happy to help. But thank you guys so much for joining me and supporting me and watching. I absolutely love you guys. So enjoy the rest of your day and your time.